This is question 3 part C, and we need this information from the previous question to answer this. So C, it says explain using physical principles the meaning of these results by considering the limiting cases when p approaches 0 and when p tends to infinity. Okay, there was actually another one as well that said C2 equals C1 over P. So this is a common theme in physics where they like to explore the limits where something approaches 0 and when something approaches infinity. You might have encountered that in statistics, I think is where it occurs very often in calculus. But the way to approach this is to substitute p equals 0 into each of these 1, 2 and 3 equations, see what arises out of it, and see what that would mean in terms of the circuit that has been considered. So here's a quick sketch of the circuit that's been considered. You had C1, which was initially charged, I believe, and C2, which was initially, so it's charged. C2 was initially uncharged, and there was a switch, I should say. There's a switch in here, and it opens and closes. But so when p approaches 0, let's look at each of these formula. For formula 1, I'll do it that way. When c approaches, when p approaches 0, that means Q1 the final charge stored on Q1 is going to be equal to Q times a very, very small number, roughly 0, over 0 plus 1. So this is basically a 0 term, which means Q1F is going to go to 0 as it approaches it. If you put in a really, really small number, you're multiplying that really, really small number by Q, so it's going to be close to 0. So the charge stored on capacitor 1 is going to 0. If I've got myself right, that's if that is 0. Number 2. So equation number 2 was Q2F. Where are we? I'll just bring it up there. Q2F, so charge stored on 2, is equal to Q times 1 over p plus 1, which is 0, so 1 over 1. So what that means is the entire amount of charge, so that one's going to be 0, and this one's going to be all of Q. So this means as p goes to 0, all of the charge will be on Q2. Okay, I might have got this a little bit mixed up. No, I didn't. No, I've got it right, going the right way. That's good. So, and then the final equation, equation 3 here, as p goes to 0, very, very small, that means C2 goes to a very, very large value, which is in keeping with this charge being entirely stored, the total charge available being stored on Q2. So what would that mean? That would mean that C2 is really, really big capacitance. That means C2 is a I don't know what we'll call it, an electron sink, and you would have none of the charge remaining on C1 since C2 is really, really ginormous, and the equations show that. Okay, so now what about when we look at the other case, the infinity? As well, let's deal with the first one here. We've got, remember, is this going to be too hard to see? Q times by the equation would be p over p plus 1, so infinity over infinity plus 1, that's essentially 1, which means Q1 is going to be essentially, because infinity over infinity, any number over infinity is roughly, you can't add 1 to infinity and have it really matter. So this term is going to equal roughly 1. For this one, it was 1 over p plus 1. So the bottom term is going to go to infinity, which means this is vanishingly small, which means you'll have the reverse in this case, where 0 charge is stored on Q2. So in the second case it's going to be 0, and pretty much all of it, all of the charge Q is stored on C1. So in that case, C2 is, no charge is going to flow in the circuit even when the switch is closed. So that means C2 is going to act like an open switch or a break in the circuit, or just two wires ending at a point. It's the minimum possible capacitance you could have with two wires just joining. I guess two wires, if you were to zoom in, each of the two wires would have a small flat end which would have a certain amount of capacitance. You could draw an electric field between them, but it would be so minute and so small because it's the end of a piece of wire cut off that it's basically zero capacitance. And if we go up to our other equation here, we can see as P goes to infinity, that means this divides down to be basically nothing. Yeah, so I think we've pretty thoroughly answered that question. Yep, very good.